22க்கும் உள்ள பேட்ச் தானா?
combined batch. A22 C22.
Okay.
A20 BCA. MCA MSc IT BCA combined.
Okay sir, okay.
Okay. Let us start. Computer network. First definitions. Computer. What is computer network? Okay. So 30 years back, ஒரு 30 வருஷத்துக்கு முன்னாடி network usage is very limited, very rare. Okay. சொல்லுங்க. Yes. ஒரு 30 years back network usage வந்து very limited. Okay, everyone they use standalone computer. So all the work, computer work, it has done in a single computer. There was no data sharing. Okay, how they can share a data? So through the hard disk, floppy disk and hard disk. Through physical transmission, data is transferred from one system. ஸோ இடையில யாரும் மியூட் பண்ணாதீங்க. சில பேர் டிஸ்டர்பன்ஸ் பண்ற மாதிரி இருக்கு. ஏன் 250 பேருக்கு அட்டென்ட் பண்றாங்க. நான் ஒவ்வொருத்தரையும் பார்க்க முடியாது, வாட்ச் பண்ண முடியாது. மியூட்ல வைங்க, அன்மியூட் போடாதீங்க. என்ன ஏதோ மியூட் பண்ணாதீங்க. அப்புறம் யூஸ் இருக்காது, கிளாஸ் எடுக்கிறது வேஸ்ட் ஆயிரும். ஓகே சார், ஸ்டார்ட் பண்ணலாமா? ஓகே, டிஸ்பிளே வருதா? ஹலோ, டிஸ்பிளே வருது
சார்? வருது, கொஞ்சம் ஸ்கிரீனை பெருசாக்கிங்க சார்.
அந்த அவங்க அட்மிட் பண்ண வேண்டியதா இருக்கா, அதுதான் ப்ராப்ளம். ஜாயின் பண்றாங்க இல்லையா?
ஓகே ஓகே,
அதனாலதான்.
சரி மகா.
உங்க அன்மியூட் பண்ணுங்க. யார் இது 6041? Right? Computer network, a collection of computing devices that are connected in various ways in order to communicate and share resources. So data computer network மூலமா டேட்டா வந்து ஈஸியா டிரான்ஸ்ஃபர் பண்ணலாம் ஒரு சிஸ்டம்ல இருந்து இன்னொரு சிஸ்டத்துக்கு. ஓகே, கனெக்டட் டிவைசஸ், collection of computing devices. Computing devices means laptop, desktop, and palm top, okay, and mobiles. So these are the computing devices. So which are the devices are connected? Which are the devices? And also printer, okay, through Wi-Fi we can connect our printer to the system and we can take printout. So all the computing devices that are interconnected, that is called a computer network. So in why we have to connect, interconnect, so to we can share resources. So printer is available in one system, okay. If systems are interconnected, so we can share printer, and one system is equipped with hard disk and CD, compact disk, and other resources, scanner, okay. So one system is equipped with all peripheral devices. ஒரு சிஸ்டத்துல எல்லாமே இருக்கு. But other system only computer terminal is also available. Terminal, mouse, and also system tower. So if all the systems are interconnected, we can make use from other system. The resources can be shared. So for that purpose, for sharing of resources, we can interconnect all the system, all the computing devices. Okay, next. The connections between computers in a network are made using physical wires or cables. So connections எப்படி நம்ம provide பண்ண முடியும்? Through cable. Through cable only we can make a connection from one system to another system. So that connections may be wired or may be wireless. So wireless ஆவும் இருக்கும். However, some connections are wireless. Okay, wired connection ஆவும் இருக்கும், wireless connection ஆவும் இருக்கும். That is a definition, a collection of computing devices that are connected in various ways in order to communicate and share resources. Another things. So the generic term node or host refer to any device on a network. If any system is connected to the network or internet, we say that is called a node or host. A data transfer rate, the speed with which data is moved from one place on network to another. The speed with which data is moved from one place, ஒரு பிளேஸ்ல இருந்து இன்னொரு நெட்வொர்க்கு ட்ரான்ஸ்ஃபர் பண்றோம். அந்த ஸ்பீடு தான் என்ன சொல்றோம்? Data transfer rate. We can transfer data or we can move data from one system to another system on a single network. That is called a data transfer rate. Data transfer rate is a key issue in computer network. So transfer rate, it should be must fast, okay, per second at 1 GB, at 1 gigabit data, and 1 terabit of data. It can be transferred from one system to another system. Next, computer networks have opened up an entire frontier in the world of computing called the client server model. So there are different in a network, there are different server model. Okay, so there are different models. OSI model, client server model, TCP IP models. So the computer networks have opened up an entire frontier in the world of computing called the client server model. Request and a client can make request the server. The server, it can process the client request. After processing, it's respond to the client. It send output or processed data. The client, it can make a request. The server, it can process the client request. That is called a client server model. There are different server. File server, web server. What is mean by file server? A computer that stores and manages files for multiple user on a network. So the computer file server is also a computer which stores and manages file for multiple user on a network. So all the data, it will be stored in file server only, where which are the user can request data. That request is considered or processed by a server, and it will send a data or file to the client. So that is a file servers. It is also a computer. Next, web server, a computer dedicated to responding to request from the browser client for web pages. So web server means, so a client computer is called a client. So that is a through browser we can send the data to the server. So the server, it is available somewhere in the world. அது எங்க வேணாலும் இருக்கலாம் web server. Okay, it is processed by it is a web server. Okay, after processing it sent to the client. So in web server model we need browser. Here browser is acting as a client. Through browser we can communicate with the web browser. So basically there are two type of server, file server and web server. Next, local area network. A network that connects a relatively small number of machines in a relatively close geographical area. So that is called a local area network. So you see the definition. A computer network, often simply referred to as a network, is a collection of computer and devices interconnected by communication channel that facilitate communication among user and allow user to share resources. So, okay, next thing. Local area, that is types of network. Local area network. There are three types of network: LAN, local area network, metropolitan area network, and wide area network. Okay, so there are three types. So in which the types of depending on volume of usage, depending on geographical area, we use concerned network. So here a LAN connects network devices. A LAN connects network devices over relatively okay, a relatively short distance. A networked office, building, school, or home usually contains a single LAN. Through sometimes one building will contain a few small LAN, perhaps one per room, and occasionally a LAN will span a group of nearby buildings. In addition to operating in a limited space, LANs are also typically owned, controlled, and managed by a single person or organization. So the local area network, it is managed by single person or an organization, okay, or company. So the local area network, it has a short in the distance up to 2.5 kilometers, it will work. So we can use local area network in school, college, and offices, okay, and other commercial areas, commercial buildings. We can use local area network. So through, in local area network, all the computers are connected through cables. Next, metropolitan area network. So a MAN is a larger computer networks that usually spans a city or a large campus. So to connect an entire city, we use metropolitan area network. The cable TV system. It works based on metropolitan area network. A man usually interconnects a number of local area network using a high capacity backbone technologies. A man it connect group of LANs such as fiber optical link and provides uplink services to wide area network or WAN and other internet. So telecommunication department, cable TV network, cable modem. These are the applications for metropolitan area network. It connect only major cities. So a company it has different many branches in a country. Okay, to connect all branches, they use metropolitan area network. A WAN is a geographically dispersed collection of lands. So the wide area network, it connect continents, different continents, or it connect entire world. So a system or computer connected in the wide area network is called host. That is internet. Okay, so yeah, WAN, the internet is the largest wide area network spanning the earth. It connects entire span. A wide area network is a geographically dispersed collection of lands. A network device called a router. A network device called a router connects local area network to a wide area network. A WAN it connects several MAN and several LAN. It connects LAN and MAN. It is called a wide area network. In IP networking, the router maintains both a LAN address and a WAN address. So these are three types of network: local area network, metropolitan area network, wide area network. Okay, we can move next. That is a difference between local area network and wide area network. Diameter of not more than few kilometers. Diameter of not more than few kilometers. So here span entire country or entire earth. Second one, a total data rate of at least several megabit per second. Nowadays, data rate is several GPPS, gigabit per second. Okay, data rate less than 1 megabit per second. Nowadays, it is in several MBBS. Data rate is very MBBS. And third one, complete ownership by a single organization. The land it is maintained or owned by single person or single organization. But when owned by multiple organization, wide area network, it is maintained by multiple organization. Very low error rate. Error rate is very low. Here, a high error rate is very high because in wide area network, data is transferred through wireless. In local area network,
Sir, your mic got muted, sir.
Network topology is the layout pattern of interconnection of various elements. So, layout topology means layout of network. That is a cables, node, links, connection of nodes. The connection is provided through cable. Okay, the entire cable structure is called topology. Depending on the space or premises available, we can form a network within a room, within the apartment, in multi-storied building, in a very large campus. We can form a network cable structure. That cable pattern is called topology. So depending on the spaces available, we can use different type of topology. Okay, depending on the spaces available, we can use different type of topologies. That is, these are type of topology: star topology, bus topology, ring or circular topology, tree topology, and graph and mesh topology. There are various topologies. Depending on the premises, we can use. Star network or star topology are one of the most common computer network topologies. In its simplest form, a star network consists of one central star network or one of the most common computer network topology. In its simplest form, a star network consists of one central switch, hub or computer. So there may be a central switch or hub in the star topology which act as a conduit or to transmit data, to transfer messages or data. The hub or leaf node and transmissions lines between them form a graph with the topology of a star. So that is a star topology, which is a central hub. Okay, central hub, these are the computer nodes. So through central hub, data will be transferred from one system to another system. No data directly transfer from one system to another system. Through hub only, data it will be. So the a computer, it send data to hub. The hub, it can forward a data to another ones. Ring topology, star topology, bus topologies. A configuration that connects all nodes in a closed loop on which messages travel in one direction. The data, it will travel in one direction. That is ring topologies. Okay, in a circular manner, systems are connected. Okay, so there will be a small token. That token is circulated on the path of the topologies. So if any one system transfer a data, it should capture a token. எந்த சிஸ்டம் டேட்டாவை டிரான்ஸ்ஃபர் பண்ணணுமோ அந்த சிஸ்டம் டோக்கனை கேப்சர் பண்ணணும். கேப்சர் பண்ணாதான் டேட்டா டிரான்ஸ்ஃபரை இனிஷியேட் பண்ண முடியும். டோக்கனை கேப்சர் பண்ணாம டிரான்ஸ்ஃபரை இனிஷியேட் பண்ண முடியாது. So once data transfer is completed, that token is released by concerned node or computers. Next, star topology, a configuration that centers around one node to which all others are connected and through which all messages are sent. Okay, so all a configuration that center around one node to which all others are connected and through which all messages are sent. So in a central hub, all the systems are connected to the hub. Okay, so any system it want to transfer a data, first it send a data to hub. From the hub, data is sent to the intended recipient. That is star topology. Next, bus topology. All nodes are connected to a single communication line that carries messages in both directions through single cable. And all the computer, more than one computer or node, it is connected. This example: ring topology, star topology. Here only one hub, two hub transfer. Through hub, data is transferred to star topology. And bus topology, there is a single communication cable. Through one cable, several computers are connected, interconnected. In star topology, there is a centralized system, computer or hub. Through central node, data it will be forwarded from one point to another point. Ring topology, there is a token is on the path of a ring. If any system want to send a data, it should capture a token, then it make a data transfer. Once data transfer is completed, the token it will be released by concerned system. That is ring topology, star topologies. That is internet connection. Internet backbone, a set of high-speed networks that carry internet traffic. A set of high-speed network that carry internet traffic. These networks are provided by companies such as AT&T, GTE, and IBMs. Internet service provider, ISP, a company that provides other companies or individual with access to the internet. Okay, like BSNL, Geo, or Airtel. So they are a ISP, internet service provider. So a company that provides the ISP, it provides internet access to other company or individual. There are various technologies available that we can use to connect a home computer to the internet. How we can connect our system, our home computer to the internet. So there are various technology. A phone modem converts computer data into an analog audio signal for transfer over a telephone line, and then a modem at the destination convert it back again into data. Okay, so at the home, that is 10 years back, we use only the dial-up connections. So our system is connected to the phone cables. Okay, at the other end, the phone cable is connected to the ISP. Okay, between ISP and home, there will be a modem. So this modem, it convert an analog signal to digital signal.
मोटू पतला था देख मोटू और पतलू की जोड़ी अति बदलता चलो चल टीवी
So 20 years back, how the home computer is get connected to the internet or web servers. In every home, okay, there is a telephones. So that telephone, through telephone cable, computer is connected to the internet server or web servers. That is called the dial-up connections. Okay, so dial-up connection means at a time either we can make a call or we can do surfing on the net. So after that, there is a broadband connections. In broadband connections, at a time we can make a phone call as well as we can surf on the net, internet. So these facility are available in the that is a DSL or broadband connection. So first we used dial-up connection. Second, when we use broadband. Third one we use DSL. A digital subscriber line uses regular copper phone line to transfer digital data to and from the phone company's central office. So the DSL or ADSL, there are two advanced technique. It connect phone to the computers via phone. It may connect to the our system into the web servers. So in earlier days we use broadband connection and dial-up connection. After that we use DSL or ADSL, digital subscriber line. ADSL means asynchronous digital subscriber lines, which connect our phone to the computer, then it will connected to the internet servers. Third one, cable modems. A cable modem uses the same line that our cable TV signal comes in on to transfer the data back and forth. So the cable television operator, they use cable modem. Okay, first they use cable modem to provide telecasting or TV programs. After that they use this antenna. Nowadays every cable TV operator has one or many this antenna. Through this antenna they connect our computer to the internet. Okay, so there are various technology, phone modem and DSL and cable modems. So before that we use dial-up connections and broadband connections. After that DSL, ADSL and also digital subscriber line and cable modems. Another one, broadband. Broadband, a connection in which transfer speed are faster than 128 bits per second. DSL connection and cable modems are broadband connections. DSL connection and cable modem both are belongs to cable broadband connections. The speed for downloads, getting data from internet to your computer, it may not be the same as uploads, okay, from your computer to the internet. So here the download speed and uplink upload speed is very important in the internet. If download and upload speed or capacity is increased, we can transfer any size of data. That is 100 GB data, 50 GB data, 1 terabyte data, it can be transferred. Okay, depending on the speed, if speed is high, we can transfer more amount of data. If speed is very low, we can transfer through high end of data. Next. இப்போ கவனிக்கிறீங்களா? ஹலோ, கவனிக்கிறீங்களா?
Yes, sir.
To improve the efficiency of transferring information over a shared communication line, messages are divided into fixed size, numbered packets. That means how we can improve the efficiency of transferred information. So that means to improve the efficiency of transferring information over a shared communication line, messages are divided into fixed size, numbered packets. So the entire message, it will be divided into several packets, 100 packets or 200 packets or 300 packets. Okay, day every day you can collect we can improve the transferring speed. The network devices called routers are used to direct packets between networks. So here we use routers in local area network, in metropolitan area network we use router. So that router is direct packet between the networks. For example, okay, so for system 1 and system 2 we are not network devices called routers are used to direct packets between networks. Each message, it consists of 50 or 100 packets. These packets are routed independently in a computer network. Okay, before reaching the destination, all the packets, it will be assembled, okay, then it will be delivered to the destinations. Okay, these are the how the data it will be delivered in the network devices. That, for example, source, it sent a message. This message split up into packet 1, packet 2, packet 3. This packet 1, 2, 3, it will be sent to other recipient. There are also n into n users. For 10 users, 10 input user, 10 output user. Okay, here 3 packets you have transferred to destination. From the destination, it transferred to packets between networks. Network devices called routers are used to direct packet between networks. Here, system send a message. That message divided into 3 packets. That packet 1 is reached to packet here packet 1, packet 2 it reached to there packet 2, packet 3 is reached to packet 3. Then these information from the packet are reached to the receiver recipient. Next, open system. Here open system means between two entity data is transferred from one system to another system. Between two entity data is transferred from one system to another system. Bhuvaneswari, mute. Proprietary system, interoperability system. What is mean by proprietary system? A system that uses technologies kept private by a particular commercial vendor. One system could not communicate with another, leading to the need. So here proprietary system means a system that uses technologies kept private. One technology is kept private by a particular commercial vendor. For example, Microsoft Office, which is a product of Microsoft Office, a product of Microsoft Corporation. If we want to use Microsoft product, MS Office, okay, and also Windows, Windows OS, Windows 10. So to use these software, we get prior permission or we get license from the proprietors. Okay, so that is a proprietary systems. Interoperability. What is mean by interoperability? The ability of software and hardware on multiple machines and from multiple commercial vendors to communicate. So there are different machines. Each machine, it has its own format, it has its own coding system and everything. Okay, similarly another system, it belongs to different vendor and different coding systems. So to communicate these two systems, there is a common pattern that is called a interoperability softwares. We can use our two-wheeler in any one of the oil companies, petrol bunk. So the ability of a software and hardware on multiple machines and from multiple commercial vendor to communicate. So different software, different hardware is supported by the interoperability softwares. A single system, it has Unix, Linux OS and Windows OS. Okay, so both operating system, it works different coding systems. Okay, and number of bits, transferred bit and accepted bit, it will be differ. So to communicate both operating system, we need common interoperability software. Another one, open system. Systems based on a common model of a network architecture and a suite of protocols used in its implementations. So open system means between two open entities, data transfer, it can be possible or it can be achieved. That is called open systems. So first one, proprietary system. So we get permission from the concerned proprietor. Interoperability, to make use different kind of OS, different software of a computer, we install interoperability software. And open system, between two open entity, we can transfer data from one system to another system. So OSI layer is the open system. The international organization open systems. The International Organization for Standardization, ISO, established the Open System Interconnection Reference Model, OSI reference model. Each layer deals with a particular aspect of network communications. Okay, the OSI reference model, it has 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Okay, so on the recipient side, the data, it passes through 7 layers. Okay, and reach the, and through cable, it data is transferred and reach the host or recipient. From the sending side, data is processed through 7 layers. On the recipient side, data is processed through 7 layers. Then it reaches the host computers. So at both end, data is transferred through 7 layers. So the number of layer, function of layer, okay, is differ from system to systems. In OSI layer, I think there are 7 layers in OSI system. But that is OSI reference model, there are 7 layers. In TCP IP reference model, there are 5 layers. In ATM reference model, there are 3 layers. So the function of layer, number of layer, ஏன்பா பேசுறீங்க? ஜாகிர் மாசத்துல ஒரு நாள் லீவ் தரணும்ல 6 மாசத்துக்கு.
Will you provide with PowerPoint, sir?
Yes.
In our official website, sir.
Which one?
இந்த PowerPoint எப்படி கொடுப்பீங்க சார்?
Through mail. I will send your mail. Any one of mail.
Shall
You
I put my mail in chat, sir?
you can share to other students.
I'll put it in chat, sir. My mail ID.
Yes, yes, yes. Yes, yes.
PCA I will be sharing, sir.
You can put in chat box and I will send you.
Thank you, sir.
So
சார் F5 press பண்ணீங்கன்னா கொஞ்சம் ஃபுல்லா வியூ ஆகும்னு நினைக்கிறேன் சார்.
எப்படிங்க?
F5 குத்தீங்கன்னா அந்த கண்டென்ட் ஃபுல்லா டிஸ்ப்ளே ஃபுல்லா வரும்ல சார்.
No problems, sir, but disturbance, I have some disturbance from your side. Some of you joined late and some of you talking. There is a disturbance from your side. So that I have to change the screens.
Oh. Okay, sir.
Yes, yes, yes. No problem.
Sir, I have sent my mail ID through chat, sir. BCA I will send, sir. Full group. Sir, I have sent my mail ID, sir, through chat. Sir?
Okay, I will send later. Okay. So each layer deals with a particular aspect of network communications. I think each layer. So each layer it has well-defined function. Well-defined function. After performing a function, it send it to upper layers. Okay. The first on the sending side, a system, it's sending a data, it submit a data to application layer. Application layer perform a function. Then it submitted to presentation layer. Presentation layer it perform function and submitted to session layer. So and so on. Like until it reach the physical layer. Okay. So one layer it perform function and submitted to below layer. This is the method on the sending side. Once that data is reached to the physical layer, the physical layer it transfer a data to the corresponding physical layer on the recipient machines, on the receiving machines. Okay, so in the on receiving side, physical layer perform a function submitted to data link layer. Then it will be submitted to network layer. Then it will be submitted to transport layer. Finally, it will reach application layer. On the application layer of recipient machine. Then application layer submit a completed message to the host B or recipient machines. So these are the procedures. Topics: OSI reference model, services in the OSI model. OSI reference model is an internationally standardized network architecture. OSI means open system interconnection. It deals with open system, that is systems open for communication with other system. Between two open entities, data is transferred. That is called an open system interconnection, specified in ISO 7498. It has 7 layers. That is layer 7 application layer, layer 6 presentation layer, layer 5 session layer, layer 4 transport layer, and layer 3 network layer, 2 data link layer, layer 1 physical layer. So layer 1 to 4 relate to communication technology. Layer 5 to 7 relate to user applications. Here layer 1, 2, 3, it will be work in within the network. Within the network, layer 1, 2, 3 it work. So outside the network, across the network, layer 4, 5, 6, 7, it will works. Okay, but layer 1, 2, 3 are enough to work within the network. Okay, layer 4, 5, 6, 7 are enough to work across the network. That means one network to another network, to connect one network to another network. The function of application layer. So I already said each layer, it has well defined functions. Layer 7 application layer, level at which applications access network services, represent services that directly support software application for file transfer, database access, and electronic mail. So for this application, software applications, it support application layer, database service, data dictionary, and NNTP, network news transfer protocol, file transfer protocol, and the electronic mail. For these application, to work with these application, we need application layer 7, layer 7 application layer. And presentation, what is the function of presentation layer? Related to representation of transmitted data. Translate different data representation from the application layer into uniform standard format. So each day system, it has its own coding system. ASCII coding system, EBCD coding system, Unicode system. Each vendor, okay, each motherboard vendor, it follows different coding system. Okay, data created in one coding system is not supported with another coding system. To interrelate these, we need one data conversion method, data structure. The data structure, it represent data in its own system, for its own systems. If we send a data in 5-bit, it convert into 7-bit. If we send data in 7-bit, it convert into 5-bit. It represent different coding systems, and also translate from one type to another type. So this work is done by presentation layer, providing services for secure, efficient data transmission. It provides data encryption and data compression. So the data presentation layer, it do data compression work on the sending side. On the receiving side, data, it will be decompressed, and on the sending side, data encrypted. Data is encrypted. Okay, it will encrypted means it original data, it will be converted into some unmeaningful, meaningless data. That is encryption. After reaching the recipient machine, encrypted data, it will be decrypted. It back to the original text. So that conversion work, that compression work is done by presentation layer. Layer 5, session layer, allows two applications on different computer. Allow two application on different computer to establish, use an NDA session. File transfer, remote login. To connect to the remote login, we need session layer. It establishes dialog control, regulates which site transmits plus when and how long it transmits. When it has to transmit a data and how long it has to transmit a data. That is establishes dialog control. So traffic regulation that is controlled by session layer. Third one, perform token management and synchronizations. Okay, so that is it allow two application on different computer to establish, to use an NDA sessions. The same application, it can be used in two computers. The second one, establishes dialog control to transfer a data. And token management, okay, which one access the resources. Okay, there is a deciding policy, policy deciding. There are multiple system in a network, or several, more than one system, it requires a printer. More than one system, it requires a scanner. Okay, so based on the priority, which one access first? Based on the priority, all these user has a token. All the users has been issued token. So based on the token number, the system is allowed to access the resources. That is called token management and synchronization. Number 4, transport layer manages transmission packets, repackages long messages and when necessary into small packets for transmission, reassemble packet in correct order to get the original messages. So it will be it will be disassemble of the packet on the sending side and reassemble of the packet on the recipient side. Okay, and packages and repackages, attaching the address information, trailer information on the sending side. On the receiving side, it remove the trailer information or header information. Packaging, repackaging. First one, manages transmission of packets. Second one, handles error recognition and recovery. Transport layer at receiving acknowledges packet delivery. It ensures error-free delivery of a single message. That is a transport layer. Resend missing packet. During sending, any packet is lost, any packet is missed, that packet, it will be resent. That is transport layer. Network layer manages addressing a routing of data within subnet. So within the network, data it will be transferred, data it will be managed. Okay, so it will not require outside. Addresses messages and translate logical address and names into physical address. Each host, it has maintain physical address and logical address. Okay, physical address, source ID, and destination ID. So between source and destination ID, there are several router ID. Data passes through several routers. Router ID is called logical address. So the network layer, it has to map the logical address. So addresses messages and translate logical addresses and name into physical address. Determines the route from source to the destination computer. The network layer only decide to which route data has to pass or packet has to pass. Which route is shortest route? Okay, it is decided by network layer. Manages traffic problem. If there is any traffic in the communication channel, or it is congested, data is congested, it will be decongested by network layer. That means that is congestion control. If a traffic problem arises, it will be resolved by network layer. Routing based on static table determined at start of each session, individually determined for each packet, reflecting the current network load. That is, manages addressing routing of data. Second one, routing can be based on static table and determined at start of each tables. Second one, data link layer packages raw bits from the physical layer into frames. So data link layer, it receives data from network layer. So on the receiving of bits, it will be make up into frames. Okay, so on receiving of binary bits, it will be make up into several data frame. Each data frame, it consists of 10 KB or 10 bytes or 100 bytes or 10 KBs. Okay, provides reliable transmission of frames. And it waits for an acknowledgement from the receiving computer. If one frame means several bytes. If one frame is sent to recipient, okay, so after receiving acknowledgement, it send another data frame. Okay, so upon receiving of acknowledgement, the sender it send data frames. The retransmit frame for which acknowledgement not received. If any acknowledgement is not arrived for that frame, particular data frame, it will be resent. Layer 1, physical layer, transmits bit from one computer to another. Okay, it transmits from one computer to another computer, regulates the transmission of stream of bits over a physical medium. So physical layer only transfer data to another system through transmission mediums. Okay, and regulates transmission of stream of bits over physical medium. How many bits it has to send per second, it defines how the cable is attached to the network adapter and what transmission technique is used to send data over the cable. That is, transmission technique means that is under simplex, half duplex, full duplex. Deals with issues like definition of 0 and 1. How many volts represent 1? How long a bit lost? 0 voltage for off, 1 voltage for on. Whether the channel is simplex or duplex. How many pins a connector has and what function of each pin is. There are different here pin means, so in each printer and modem there is a pin, 25 pin
Sir, voice is not audible, sir.
I think you are muted, sir.
So there are 7 layers in the ரொம்ப நேரமா மியூட்ல இருக்கா இப்பதானா
ஒரு 3 minutes.
ஒரு 5 to 3 minutes இருக்கும் சார்.
ஓ இது வாட்ச் பண்ணீங்களா இது இது வாட்ச் பண்ணீங்களா
எஸ் சார், இது வாட்ச் பண்ணோம். கரெக்டாக வந்து அப்ளிகேஷன் லேயரில் போச்சு. சாரி, லெவல் 1ல போச்சு சார்.
லேயர்ஸ் அப்ளிகேஷன் லேயர் பாத்தீங்க பார்த்தாச்சு.
எஸ் சார்.
செஷன் லேயர் பார்த்தாச்சு.
எஸ் சார், ஃபர்ஸ்ட் லேயருக்கு அப்போ தான் கட் ஆச்சு.
இது நீ டிரான்ஸ்போர்ட் இதுவா?
இது இல்லை சார், லேயர் 1.
லேயர் 1. லேயர் 7, லேயர் 6, லேயர் 5, லேயர் 4 டிஸ்கஸ் பண்ணோமா?
எல்லாமே பண்ணோம் சார். பண்ணேன் சார்.
கட் ஆயிடுச்சா?
இல்லை சார், பண்ணோம் சார்.
நெட்வொர்க் லேயர் டிஸ்கஸ் பண்ணியாச்சு.
எஸ் சார்.
டேட்டா லிங்க் லேயர், டேட்டா லிங்க் இதுல தான் கட் ஆயிடுச்சு இல்லையா? பிசிக்கல் லேயர்.
எஸ் சார். எஸ் சார், பிசிக்கல் லேயரில் கட் ஆச்சு.
பிசிக்கல் லேயர் அப்படிங்கிறது ஃபர்ஸ்ட் லேயர். பட் சென்டிங் மிஷினுக்கு வந்து லாஸ்ட் லேயர். சென்டிங் மிஷின் ஃபர்ஸ்ட் ஸ்டார்டிங் வந்து அப்ளிகேஷன் லேயர் தான். சென்டிங் மிஷின்ல ஃபர்ஸ்ட் அப்ளிகேஷன் லேயர் பெர்ஃபார்ம் ஆகும். தென் அப்ளிகேஷன் லேயர்ல என்ன பெர்ஃபார்ம் ஆகும்? இமெயில், டேட்டா டிக்ஷனரி, டேட்டாபேஸ் கனெக்டிவிட்டி, ஃபைல் டிரான்ஸ்ஃபர், ஸோ இந்த மாதிரி டேட்டாலாம் அப்ளிகேஷன் லேயர். ப்ரெசன்டேஷன் லேயர் என்ன ஃபங்க்ஷன் பெர்ஃபார்ம் ஆகும்? டேட்டா கம்ப்ரஷன் அண்ட் டேட்டா கன்வர்ஷன். அண்ட் செஷன் லேயர் ரிமோட் லாகின் கனெக்ட் பண்றது. ஓகே. அண்ட் ரிசோர்சஸ் ஆக்சஸ் பண்றது. ரிசோர்சஸ் ஆக்சஸ் பண்றதுக்கு பெர்மிஷன் ப்ரொவைட் பண்றது, அது செஷன் லேயர். டிரான்ஸ்போர்ட் லேயர் எரர் ஃப்ரீ டிரான்ஸ்மிஷன் அண்ட் டிரான்ஸ்மிஷன் ஆஃப் பாக்கெட்டை வந்து என்ஷூர் பண்றது டிரான்ஸ்போர்ட் லேயர். நெட்வொர்க் லேயர் டிராஃபிக் ரூட்டிங் வந்து டிசைட் பண்றது. ஓகே. ஷார்டஸ்ட் ரூட்டை டிசைட் பண்றது, கன்ஜெஷன் அவாய்ட் பண்றது, அது நெட்வொர்க் லேயர். டேட்டா லிங்க் லேயர் டேட்டா ஃப்ரேமை மேக்கப் பண்ணி வித்தின் எ நெட்வொர்க் டேட்டாவை டிரான்ஸ்ஃபர், பாக்கெட்டை டிரான்ஸ்ஃபர். டிரான்ஸ்போர்ட் லேயர் வந்து அவுட் சைட் தி நெட்வொர்க். Data link layer within the network. Physical layer, it transmit bit from one computer to another. Regulate the transmission of a stream of bits over a physical medium. It decides network transmission technique. What type? Parallel transfer, serial transfer, serial transfer and parallel transfer. There are 2 types of transmission technique, and there are 3 types of channels: duplex channel, half duplex channel, full duplex channels. இந்த channel decide பண்றது. So இது எல்லாம் decide பண்றது. How much volt should be applied? 12 volt, 5 volt, 3 volt. அதை decide பண்றது physical layers. The 7 layers. Repeated. Next, TIP layers. So after 10 minutes break, we continue. Okay.
Yes, sir.
Okay, sir.
Sir, I have sent my mail.
Shall we discuss? Hello. பார்க்கலாமா? ஓகேவா? ஹேண்ட் ரைஸ் பண்றாரு ஒருத்தர், என்ன விஷயம்? பார்க்கலாமா? ஸ்டார்ட் பண்ணலாமா?
ஸ்டார்ட் பண்ணிடலாம் சார் நம்ம.
ஓகே. இது வரைக்கும் நம்ம பார்த்தது டெஃபினிஷன், கம்ப்யூட்டர் நெட்வொர்க் டெஃபினிஷன் பார்த்தோம். நெக்ஸ்ட் வந்து டைப்ஸ் ஆஃப் நெட்வொர்க், அது நம்ம பார்த்தோம். அதுக்கடுத்து டோபாலஜி ஆஃப் நெட்வொர்க், நெட்வொர்க் டோபாலஜி, ஸ்டார் டோபாலஜி, பஸ் டோபாலஜி, ட்ரீ டோபாலஜி, ரிங் டோபாலஜி பார்த்தோம். அடுத்து கனெக்ஷன் மெத்தட், broadband, proprietary systems, interoperability systems, connection method பார்த்தோம். Next OSI layers, இதை டிஸ்கஸ் பண்ணோம். Next TCP IP layers. Okay. TCP IP layer. The Internet Protocol Suite, commonly known as TCP IP, is the set of communications protocols used for the Internet and other similar networks. If we want to send a data over Internet, so that data, it passes through TCP IP protocols, that is Internet protocols. Okay, so it has two parts. TCP is one part, IP is one part. Internet protocol, transmission control protocols, it has two parts. Generally we say
internet protocol. Internet protocol means that is TCP/IP. Is a set of communication protocols. Okay, if we want to send over data. If we want to send a data over internet, our data it uses TCP/IP protocols. So what the protocol it does, okay? So it's the protocol. It send data from one computer to another computers. Okay, yes, that is computer at both end. It has different format. It has different coding system, and also it has different data representations. Okay, so it accept one format and converted into another the recipient system format. For that purpose, we need protocols. Okay, so protocol means it commonly it is a set of rules and convention. What is mean by protocol? It is a a set of rules and guidelines. Okay, so when data is transmitted, so it should follow that rules and guidelines. So that is called protocols. Rules, a set of rules and regulations. Every data transmission, it should follow that rules. There are two parts, two kind of protocols. In TCP/IP protocol, two parts. One is transmission control protocol. Another one's internet protocol, where the first two networking protocol defined in this standard. Next. So this is OSI layers. These are the layers of OSI: physical, data link, network, transport, session, presentation, applications. So these are the OSI of TCP/IPs. Application layer. So the application, presentation, session layer. These job of three layers is done by application layer. Transport layer is available. Transport layer is available. Here network layer, here inter-network layer. A job of physical and data link layer is done by link and physical layers. Here also physical layer is available. Application, transport, inter-network, and also link and physical. There is the two part. Data link layer. Data link, it is called link. Physical layer is called. Okay, so these are the 5 layers in TCP/IP, 7 layers in OSI layers. Job of 3 layers done by application layer in TCP/IP. Okay, job of data link layer, physical layer is done by link and physical layers. So these are the number of layers in OSI and TCP/IP. Next, function, application services, functions of application layer. Email, SMTP, simple mail transfer protocol. Network management, SNMP, WWW, HTTP, and other services. Email, network management, WWW, and other services. Transport, end-to-end message integrity, UDP, TCP. Okay, so here transport layer, it take care of delivery of single packet in OSI layer. In TCP/IP layer, So there are two parts, UDP and TCP. TCP, it is a reliable data transmission. TCP, data transport control protocol. UDP, user datagram protocol. So it is unreliable data transmission. For wireless transmission, UDP protocol is required. For wireless, UDP protocol is required. For wiring transmission, TCP is required. Okay, and data error recovery. TCP is also solved by error recovery. Internet protocols, connectionless, best effort, packet delivery. IP means internet protocols. It send a data from one node to another node. Internet, network interface, almost any network technologies. So in network interface means there is physical and data link layer, transfer to another computers. So there is a function, another one. TCP/IP architectural model. Application layer, it support FTP, SMTP, Telnet, DNS, SNFP, RIP. These are the services. These are the applications done by application layer of TCP/IP model. And transport layer, transmission control protocol, TCP, user datagram protocols. Okay, there is a architectural models. Internet layer, IP, internet protocols. Network access layer, subnet, Ethernet and token ring fiber, FDDI. So that is, we need physical transmission, okay, to transfer one data one place to another place. The Ethernet is a cable and FDDI is a token ring fiber. Through FDDI, computer is connected from one place to another place, one computer to another computer. These are the architectural models. So this application layer of TCP/IP is comparable to the application presentation and session layer of the OSI model, all combined into one. It provides a way for applications to have access to network services. This layer also contains the high-level protocols. The main issue with this layer is the ability to use both TCP and UDP protocols. Example, TFTP uses UDP because usually on a LAN, the physical link are short enough to ensure quick and reliable packet delivery without many errors. SMTP instead of uses TCP because of the error checking capabilities. Since we consider our email important information, we would like to ensure a safe delivery. Next, transport layer. UDP, user datagram protocol, offering a direct way to send and receive datagram over an IP network with very few error recovery services. Here UDP means that is a datagram service. Okay, through it is a wireless service. Through wireless, that user datagram protocol is available. TFTP, trivial file transfer protocol, simplified version of the FTP protocol, which has no security features. So there is a transmission of data in TCP/IP. Host means our laptop. Target, web server. HTTP. Okay, through HTTP, data is passed, and transport layer Application layer is done on HTTP protocol. Transport layer is done on TCP protocol. Network layer, internet protocols. So each layer require one protocol, data link layers. Okay, from the data link layer, it transfer to the media for data transfer. That is Ethernet. That is a cable. From the Ethernet cable, it put to data link layer, then network layer, transport layer, application layers. Another thing, transport layer. This layer acts as the delivery service used by the application layer. Again, the two protocols used are TCP and UDP. The choice is made based on the application transmission reliability requirements. The transport layer also handles all error detection and recovery. Transport layer also handles error detection. It detects the error as well as it corrects the errors. That is the job of transmission transport layers. It has two protocols, TCP and UDP. TCP is a reliable communication protocol, communication service. UDP is the unreliable service, connection, unreliable connection. It uses checksum, acknowledgement, and timeouts to control transmission and end-to-end verification. That is transport layer. Transport layer uses checksums, acknowledgement, and timeout to control transmissions and end-to-end verification. Unlike the OSI model, TCP/IP treats reliability as a end-to-end problems. So in OSI, okay, so there are some unreliable, in some case that is unreliable, because between two open entity data it will be transmitted. In TCP/IP, it treats reliability as an end-to-end problem. Between two entity, data is sent with secure. So that is a reliable. Compared to OSI, TCP/IP is a most reliable protocols. Next, internet layer. So this layer is also known as internet layers. So the main purpose of this layer is to organize or handle the movement of data on network. This layer is also known as internet layer. The main purpose of this layer is to organize or handle the movement of data on network. So if the data it moves from one place to another place, we require internet protocol. By movement of data, we generally mean routing of data over network. The main protocol used at this layer is IP, while ICMP used by popular ping command and IGMP are also used at these layers. We require ICMP and IGMP. Next. NIC, network interface card. So in this network interface card, the network architecture is done. Both the device driver and network interface card take care of communication detail with the media being used to transfer data over the network. To transfer data from one computer to another computer, it mainly involves a network interface card and device drivers. In most cases, this media is in the form of cables. Some of famous protocols that are used at this layer include ARP, Address Resolution Protocol, PPP, point-to-point protocols. ARP means Address Resolution Protocol, PPP means point-to-point protocols. So that is the concept of TCP/IP layer. Next thing, there are two types of technology in network: point to point and multi point. What is mean by point to point? Point to point means, that is, a point to point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. Either there is station A, station B, but between two stations there is a one communication link or cables. So station A sending a data directly to the B, station B. So no, in between two systems, no other systems. Station A directly sent to station B. There is point to point communications. And multi-point, a multi-point connection is one in which more than two specific devices share a single link. Okay, the single communication link is shared by multiple stations. In a multi-point environment, the capacity of the channel is shared either spatially or temporarily. So this channel, it will be shared by multiple system or devices. If several devices can use the link simultaneously, if several devices can use the link simultaneously, it is spatially shared connection. If user must take turns, it is a time shared connections. So, some connection it may be time shared within particular time period. Link it should be available to the particular users. Okay, and spatially means several devices can use the link simultaneously. More than one devices can use the same channel. That is spatially shared channel. Direction of data flow. So that is a mainframe. This is one direction. Communication between two devices can be simplex, half duplex, full duplex. This is the one direction only. Mainframe monitor, simplex. B, half duplex. Station A, it's sending a data to station B. Okay. So the station A, it's sending a data to station B. After receiving data, station B, it's sending a data to station A. So at a time, any one device, it communicate to other system. Okay, not simultaneously, but full duplex. Okay, so it has two cables in full duplex. Here there is one cable, that is wrong. There are two cables. One, when one station communicating to another one at the same time, there's another one communicate to first one. Station A communicate to station B at the same time. B also communicate to station A. That is full duplex. So that is a communication between two device communication method. Next thing, internet architecture. So the internet architecture evolved out of experience with an earlier packet switched network called ARPANET. So both the internet and ARPANET were funded by the Advanced Research Project Agency. ARPA means it is a US based organization. Okay, that is funded agency. The internet and ARPANET were around before the OSI architecture. Before invention of OSI, ARPANET is available, and the experience gained from building them was a major influence on OSI reference model. Okay, instead of having 7 layers, a 4-layer model is often used in internet. So there are 4 layers used in the internet. So which already we discussed, that is TCP IP layer. Next, error. Networks must be able to transfer data from one device to another with complete accuracy. Okay, so it with accuracy, most accuracy, the node it transfer data to another one. Some part of message will be altered in transit than that the entire content will arrive intact. So many factors like line noise can alter or wipe out one or more bits of given data unit. This is known as errors. So here errors means, so bit it during transmissions data bit it can be corrupted, or it may be lost due to heat issues or technical issues. Bit is altered or corrupted. So there are two types of errors: single bit error or burst error. Single bit error means that only one bit of given data unit is changed from 1 to 0 or from 0 to 1. Burst bit error, it means that two or more bits in the data unit have changed. So so if only one bit is changed, that is single bit error. If two or more bit are changed, that is called a burst error. So this is a data unit sent by the sender machine. Here 0, 0, 0, 1, 0, 1, 1, 0. These are the bit pattern. Here these are the bit pattern received by receiver machine. Here 0, 1, 0. So here changed. Here this 1 altered to 0. This 0 altered to 1. Here 1 is 1 same. 0, 0 same. Here 0 is altered to 1. So 3 bits are changed. Okay. This is called burst error. If error is detected, first it should be deducted, then it should be corrected. Next concept, framing. What is mean by framing? It is the one of the service in data link layers. The stream of bits are not advisable to maintain in network. a group of bits, it cannot be maintained in network. When an error occurs, then entire stream have to be retransmitted. So we send 10 bit of data. That 10 bits in transmission, in transit, it may be corrupted. Any 2 bits out of 10, any 2 bits is corrupted. Okay, so we cannot continue further. So we have to retransmit again the 10 bits. So whenever error happen, we have to retransmit it. To avoid this, the framing concept is used. In this, the stream of bits are divided into manageable bit unit called frames. The group of bits, the data link layer, it received from network layer. Okay, upon receiving a bits, it make up several data frames. To achieve, we are using several ways: byte oriented, bit oriented, clock based protocol. Byte oriented protocol means each frame is considered as a collection of bytes rather than a collection of bits. There are two approaches. Each frame is considered as a collection of bytes rather than collection of bits. So each frame it considers a bytes, and there are sentinel approach. Okay, in this approach, it uses special characters called sentinel character to indicate where frames started and end. This approach is called character stuffing bit. One special character is stuffed between bits. Between bits, one special character, that is byte. Okay, to identify the start of the frame and the end of the frames. At every end of the frame, the one special character, it will be stuffed at the sending side. At the receiving side, that stuffed character, it will be destuffed, that is removed. So the newly inserted by character is removed at the time of receiving. So to identify start and receive end of the bit, we use start of the frame, end of the frame, we stuffed one character. At the receiving side, it will be destuffed. That is a sentinel approach. Okay, and byte count approach. In this approach, number of bytes in frame are counted and entered in the header. The count field specifies how many bytes are contained in the frame body. Example, digital data communication message protocol. So byte count means, okay, we can here every bit it will be counted. If number of bits are more, we identify there is some errors. Whether it is more or less, we can identify and data bits are corrupted. Okay, if number of bits are equal, okay, if we send 7 bit, at the same 7 bit is received by receiver, so there is no need of alteration. That bit it will be accepted. Okay, that is byte count. Here counting the byte, here byte count. Next, bit oriented protocol. It views the frames as a collection of bits. The synchronous data link control SDLC protocol developed by IBM is an example of a bit oriented protocol. It was later standardized by the ISO as higher level data link, controls. So there are two kinds of bit oriented protocol, SDLC and HDLC. SDLC developed by IBMs. Okay, so it is bit-oriented protocol, and it is standardized by an ISO as high-level data link control protocol HDLC. So that is a format of HDLC. It is a bit-oriented data link protocol designed to support both half-duplex and full-duplex communication over point-to-point and multi-point link. Frame format: beginning sequence, header, body, CRC, and ending sequence. The beginning sequence 8-bit, header 16-bit. Okay, body and CRC 15. Okay, and ending sequence 8-bit. So HDLC denotes both beginning and end of a frame. It denotes beginning and end of the frame with the distinguished bit sequence 0, 1, 1, 1, 1, 1, 1, 0 to guarantee that a special sequence does not appear inadvertently anywhere else in the frame. HDLC uses a process called bit stuffing. So HDLC used for bit stuffing. Next, clock-based protocols. The synchronous optical network SONET. The SONET means synchronous optical network is one of the protocol using clock-based framing protocols. What is the use of SONET? It was developed by the ANSI for digital transmission over optical network. Optical means fiber optical cables. Okay, for fiber optical cables, we used SONET protocol. It addressed both framing and encoding problems. A SONET frame has some special information to distinguish where the frame start and end. To identify beginning of the frame and end of the frame, we use SONET protocols. Next thing, error detection. For reliable communications errors. For reliable communications, error must be detected and corrected. So, during transmissions, error rate is very high in wireless transmission. Error rate is very low in the physical transmissions. So how error it will be corrected? When we sending it bits, along with bit, some extra bit it will be attached. Both data bit and extra bit it will be sent. Okay, if any bit is altered, so we can adjust with the extra bit. Okay, that is here one way of error correction method. Okay, so for longer distance we use it. For shorter distance we use some other method. One error detection mechanism is considered every data unit twice. The receiving device then would be able to do bit for bit comparison between the two versions of the data. So data unit it will be sent at the time of data what it has, it is stored in the buffer. At the time of receiving the data it will be compared with time of sending. So, okay, if any mismatching happens, data packet it will be rejected. But instead of repeating the entire data stream, a shorter group of bits may be appended to the end of each unit. This technique is called redundancy because extra bits are redundant to the information. They are discarded as soon as the accuracy of information has been determined. So we send one group of bits, 5 bits, 8 bit, 9 bits. At the same time, we send another group of bits, 001, 000, 111, or 101, another group. So both data unit and the extra bit, it will be sent to the recipients. Okay. So if any error is altered, by calculating checksum, it identify whether data bit is correct or not. By calculating checksum, it verified. So there are 4 types of redundancy check. Vertical redundancy check, VRC, longitudinal redundancy check, LRC, cyclic redundancy check, CRC, and checksums. VRC, LRC, CRC, checksum. Here we use the vertical redundancy check. It is also known as parity check. In this technique, a redundant bit called a parity bit is appended to every data unit so that the total number of ones in the unit, including the parity bit, becomes even for even parity or odd for odd parity. For verticals, you see example, the data is 01010110. VRC check. Okay, so we count number of ones odd or even. 1, 2, 3, 4. Number of 1 is even. So we attach 0, 0, 1, 0, 1, 0, 1. Okay, 1, 0, 0. Number of ones is even means we attach 0. Okay, so that along with parity bit, it will be sent. For even parity. For odd parity, the data unit is passed through the odd parity generator. It counts the number of 1 is the data unit. If even number of 1, then it's set to 1. Okay. If number of 1 is odd, we set 0. For even parity, we set 0 for number of 1 is even. For odd parity, if number of 1 is odd, we set 0. Here 1, 2, 3, 4. Here a number of 1 is even. So we set 1. So that is the original data and the VRC check. That is VRC, vertical redundancy check. Next, longitudinal redundancy check. In this, a block of bits is organized in a table. For example, instead of sending a block of 32 bits, we organize them in a table made of 4 rows and 8 columns. We then calculate the parity bit for each column and create new row of 8 bits, which are the parity bit for whole block. So this is the original data. 111011110101 00111101 So this data, it will be organized into row and order. 11100. Next to 1. Next you write down. Third one right here. Fourth one right here. Now you compare. If number of 1 is even, we add 0. If number of 1 is odd, put 1. Number of 1 is odd, 1 like this. We get another 8 bit. Okay, we send these ones. This is a longitudinal redundancy check. And next, cyclic redundancy check. First, we see vertical redundancy check. Okay. Then longitudinal redundancy check. Third one, cyclic redundancy check. CRC is based on binary division. Now we do binary calculations. In this, a sequence of redundant bits called CRC remainder is appended to the end of the data unit so that the resulting data unit becomes exactly divisible by a second predetermined binary number. At its destination, the incoming data unit is divided by the same number. At this step, there is no remainder. The data unit is assumed to be intact and therefore accepted. A remainder indicates that the data unit has been changed in transit and transport must be rejected. Here we see one example, data CRC. Beginning in CRC, beginning 000, divisor, data unit, divisor, remainder. If we get 0, accepted, non-zero means rejected. Data CRC. Okay, 00, n bits, divisor, n plus 1, CRC, n bits. So that is an example for received data. Divisor, quotient 10 10010000001101. We take binary divisions, okay, and we can subtract it. Substitute 0. By applying this division, we get 001. Okay, so that is it should be rejected. Okay, again we do binary division 1101 1001000001. Data plus CRC received 11101. Again we do binary division. So finally it get 000. So data packet, it will be corrected, it will be accepted. And this is the cyclic redundancy check by applying binary divisions. Next one, Hamming code or Hamming distance. The Hamming code can be applied to data unit of any length and uses the relationship between data and redundancy bits. Position of redundancy bits in Hamming code accept checking function reject. So input, we calculate a function and rejected. Data, generating function, redundancy check. Here original data is a redundant bit and we can use it. We can apply it. Anyone tell your mail ID?
அப்புறம் அதுக்குள்ள உத்தரவுலாம் கேட்டீங்க அப்படின்னாச்சு என்ன உத்தரவு கேட்கணுமா என்ன
I have placed it in the chat, sir.
Yes.
இதுல உடஞ்சிடுறது
Chat boxல போட்டீங்களா?
Yes, sir. நான் மென்ஷன் பண்ணிருக்கேன் சார் என்னோட மெயில் ஐடி.
சார் பிசிஏ பேட்ச்க்கு நான் போட்டிருக்கேன் சார். உமா பூஜான்னு போட்டிருக்கேன். உமா பூஜா 2002 பிசிஏ பேட்ச் ஃபுல்லா அனுப்பிடுவேன் சார். A20 பேட்ச்.
Wait. யவன பிரபா.
Yes, sir, I'm here.
யவன பிரபா. Aswin. Ananjay.
Yes, sir.
இல்லப்பா அது திரும்பி கரையேன்னு இருக்கு அது இந்தியதான் கரையேன்னு இருந்து வண்டிக்குள்ள வாசத்துல எல்லாம் போயிடுறது
அந்த உமா பூஜாவும் எடுத்துக்கோங்க சார். இதுக்கு மேல போச்சு இல்ல உமா பூஜா 2002. Thank you, sir. Received, sir.
Yes, sir, we have received.
Notes received, sir.
இந்த மாதம் நான் பெருசுனா நம்ம சொன்னாலும் இது மாதம் நான் பேசுறேன் அதை பற்றி கேட்கறதுலாம் அவங்களுக்கு சொன்னா கேட்கக்கூடிய அதுக்கு அந்த மாதிரி ஆள் இருந்தால் சொல்லலாம் மாப்பிள்ள அப்படின்னாரு.
சார் சாரி டு இன்டரப்ட். அட்டெண்டன்ஸ் எப்படி சார் சார்ட்ல போடணுமா இல்ல?
லாஸ்ட் கிளாஸ்ல நான் கொடுக்குறேன், லிங்க் கொடுக்குறேன்.
ஓகே சார், தேங்க்யூ சார்.
சார் உமா பூஜா அதையும் ஆட் பண்ணுங்க சார், கிராஸ் பண்ணிட்டீங்க. திருப்பி போடவா சார்?
வேண்டாம் வேண்டாம். இப்போ செகண்ட் டைம் அனுப்பிச்சிருக்கேன் பாருங்க. OSI லேயர், TCP IP லேயர்.
ஸோ இன்னைக்கு கிளாஸுக்கு இன்னைக்கு எடுத்த கிளாஸுக்கு எல்லாத்தையும் நான் பிபிடி அண்ட் PDF ஷேர் பண்ணியிருக்கேன். ஓகே
வந்துட்டேன் சார். தேங்க்யூ ஸோ மச் சார்.
ஓகே ஓகே, டுடே கிளாஸ் இஸ் ஓவர். நெக்ஸ்ட் சாட்டர்டே.
Okay, sir.
All of you disconnect.
Sure.
Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Sir, the attendance link comes through.
Attendance last class கொடுத்துறேன்.
Okay.
Sir, attendance, sir.
Attendance last classல கொடுத்துறேன்.
Okay, sir. Okay, sir. Okay, sir. Thank you, sir.
Thank you. Please all of you leave